Another test we're going to do in lab today is a passive agglutination test, and this one is testing for rheumatoid factor, or RF factor. So in this test, what we're going to be doing is we're going to be testing a positive control, a negative control, and a patient sample. Because the particle used in this test is a latex particle, which is white, the testing card that we use has black circles on it so that the latex particles can easily be seen when they clump. Also, because this card is black, it's hard to label the card using a marker. So what we normally do is we label where we've put the positive, where we've put the negative, and where we've put our patient. And today we have patient 1. Also included in the kit are the positive control vial, the negative control vial, and I have some patient serum sample here in a tube. So the first thing we're going to need to do is take a drop of latex reagent and place it in each of the reaction circles. So I have gently mixed the latex particles to dispense them, and there's a dropper included with this reagent vial. And I'm going to put my drop of latex reagent a little bit to the side of the circle. I'll tell you why in a moment. And 1 drop of any reagent from a dropper is approximately 40 microliters in size. The next thing we're going to do is we're going to add a drop of our positive control, again, roughly 40 microliters. And the reason we put our latex drop to one side of the reaction circle is because now our well-mixed positive control needs to be placed on the other side of that reaction circle. And the reason for this is we don't want there to be direct mixing of latex reagent with the sample we're testing, because it will cause contamination or adding of latex particles to our positive control vial and cause clumping in the vial. When we place that drop onto the circle, we also want to avoid bubbles. That's why I grabbed my other bottle of positive control, because the other one was almost empty and I was getting a bubble. We need to make sure that we have a full, roughly 40 microliter drop added to our reaction circle. So I'm going to do the same with a well-mixed negative control. I'm going to add roughly 40 microliters by adding a drop to the other edge of that reaction circle. And then I'm going to take my patient sample. Now my patient sample is going to be in a tube. I'm just using a regular glass tube that has some patient sample in it, but normally this sample would be in a serum separator tube or a red top tube where we have collected a blood sample and separated the serum from the blood cells. And so what we use to remove roughly 40 microliters for serology testing are these little sticks that I mentioned last time. If you squeeze it and then place it into the patient sample and release, it sucks up roughly 40 microliters of patient sample, and I'm doing that by avoiding bubbles. And I can place that drop in the reaction circle for patient. Okay? The other end of this stick is flattened, and that's because we can dispense patient sample with one end and then stir with the other end. So these are known as dispensers. So the next thing I'm going to do is I'm going to mix together the drop of latex particles on one side of the reaction circle and the patient sample on the other side of the reaction circle. I'm going to use a separate dispenser to mix together the negative control with the latex particles and the positive control with the latex particles. And then I'm going to start a timer for 2 minutes. In the directions it mentions this is a 2-minute reaction. And I'm going to make sure that I rotate this card for 2 minutes so that the latex particles and the patient sample have a chance to actually come in contact with one another so that antibody attached to the latex particles can come in contact with any rheumatoid factor that is present in the patient sample. Also notice that when I mixed the latex particle drop and the sample drop for the substance I'm testing, I made sure to spread those together and fill up the entire area of the circle, all the way to the red barrier or border. The reason for that is also so that we can easily see clumping of latex particles if and when that occurs. So we're simply going to rotate this card in our hands for 2 full minutes. You can already see that the reaction circle to the right, to the left, is starting to show some small visible clumps or agglutinates. The latex particles are already starting to clump together, which is what we expect in a positive control. The negative control is not showing us that same reaction. Our patient sample, we can see, is showing us that reaction, but we still need to make sure we rotate the card for a full 2 minutes. If we had a patient sample that looked negative, we want to make sure that we give it the full 2 minutes so that antibodies will have a chance to come into contact with antigens. All right, so you can see our positive control does look very positive, white clumping particles. Our negative control is still just a milky white suspension with no clumps, and our patient is very positive. So this test would be reported as positive for patient 1. Now, also in the directions, there is a semi-quantitative method. And this is a method where you would actually perform what's called a titer. And in a titer, as we discussed yesterday in the dilutions lab, is where we make doubling dilutions of a patient sample and retest each of those dilutions the same way we tested the undiluted patient sample. So in order to do that, what I have here are some labeled tubes. I'm going to make a 1 to 2 dilution, a 1 to 4, a 1 to 8, and a 1 to 16. So what I'm going to do in order to do that is I am going to actually add some buffer that is included in the testing kit. I'm just going to move these out of the way so we can center that. So this buffer that's included in the testing kit is specifically designed for diluting patient sample to repeat the test as a titer. I'm going to be adding 20 microliters of this buffer to each of the tubes. So just like the serial dilutions that we performed in the tubes yesterday, you can go ahead and add your diluent to the tube ahead of time, because the same amount of diluent is going to be needed for each of these dilutions. Okay. Next, I'm going to add 20 microliters of undiluted patient sample to the first tube to make the 1 to 2 dilution. I now have a total of 40 microliters. Taking 20 microliters and transferring it to the second tube, transferring it to the third tube, and then transferring 20 microliters to the fourth tube. Okay. Now what I can do is repeat my test using increasingly diluted serum sample from my patient. So in order to do this, I'm going to need a reaction card that has more than just three reaction circles. I'm going to use 4 reaction circles here. Because I have enough patient sample, I'm going to repeat patient 1. That is undiluted, a 1 to 1. I'm going to test the 1 to 2, the 1 to 4, the 1 to 8, and the 1 to 16 dilutions. Just as we did before with undiluted sample, we're going to add 1 drop of well-mixed latex reagent to each of the circles, of course placing it at the side of the circle, not in the very center, so that there's room to add our patient sample in the next step. Then I'm going to use a separate dispenser for each dilution. I'm going to take some patient sample out of the tube, add it to the reaction circle, and I'm actually placing my dispenser right next to the circle where I added the sample so that I can use the stirring end to mix the 2 drops in the next step. Okay. So lastly, I'm going to mix my latex drop with my patient sample in each of these reaction circles. Okay, I'm starting my timer for 2 minutes, and I'm going to rotate my card. So I'm already seeing that the undiluted patient sample is already positive again. All of the others still look negative. One of these actually does not fill the whole circle right now, so I'm just going to mix it a little bit more to make sure it's got a good reaction area there. Okay. Okay, my timer is about to go off, so I'm going to start showing you. Undiluted sample is still positive. You can see the white clumps. However, the 1 to 2 is completely, well, it's very, very weakly positive. It may be really hard to see that on this camera. Let me see if I can get it focused good enough for you guys to see. There are teeny tiny, very visible clumps there, so I would call it positive. However, the 1 to 8, the 1 to 16, sorry, the 1 to 4, the 1 to 8, and the 1 to 16 are negative. So I would say that this person has a semi-quantitative amount of rheumatoid factor that is a 1 to 2 titer, or a titer of 2. Now, 6 months down the road, if we tested this patient again, and their level was positive all the way through the 1 to 16, for example, we would know then that that person was starting to make more rheumatoid factors. So their arthritis was basically getting worse. So starting today, one of your assignments associated with lab is to do your study guide. So what I've done for rheumatoid factor, I have given you an example of a study guide. So at the top of your study guide, you are always going to put the name of the test, rheumatoid factor. Okay? The clinical significance or purpose, in Stan Bio package inserts, they put intended use. So the whole purpose of doing the test, why is it clinically significant, is that we are detecting rheumatoid factor in human serum to aid in the diagnosis of rheumatoid arthritis. It also wants to know what type of specimen requirements there are. We should collect a serum sample for this test. It gives the best reactivity. All right, I'm going to skip down to interpretation of results. Agglutination of latex particles gave us a positive result, and it tells you in the package insert that RF must be greater than 20 IU per ml for that to come up positive. If there's no agglutination, the test is negative, and so the level of rheumatoid factor is less than 20. Controls that are used. We used what are called external controls because the controls had to be added to the test card. They were not already present in the card when it was produced. Positive control, greater than 20 international units per ml. Specifically in this kit, there are 25 units of rheumatoid factor in the positive control, and negative control has no RF, so it gives us a negative result. Limitations are also listed. The reaction time. If you were to wait longer than 2 minutes and then come back and look for agglutination, you may get a false positive result. That is because the card will start to dry up over time. Lipemic serum may cause false positive reactions because agglutination can happen, but it's not because of a reaction with the actual rheumatoid factor. Stronger agglutination does not necessarily mean higher levels in the qualitative test. Okay, so I saved the principle of tests for last because this is the one that students struggle with the most. When you do principle of test, I want you to include the specific antibody that we are using and the specific antigen we are using in the test system, both for the reagents and for the patient sample. Write it out with words and draw a picture showing me a positive reaction. So for this test, and this is written out for you in the principle in the package insert, latex particles have antibodies to rheumatoid factor attached to them. This is a passive agglutination test. Then, if we add patient serum that contains rheumatoid factor, which is an IgM autoantibody, we will get visible agglutination because the antibodies attached to the latex particles will attach to the rheumatoid factor and lead to cross-linking of those particles, and that's why we saw the white clumps in the positive reactions. So you guys have this as an example for your first study guide. I want you guys to fill out a study guide for every single test that I show you via video from now on, and you must turn those in daily, and I will be reviewing them and giving you feedback.